one of my good friends and the rock star when it comes to network and network security. Paul Coggin, we all refer to him as Bubba. He refers to himself as Bubba, so if you want to be his friend, call him Bubba. Otherwise, he's called Paul. Sometimes we call him the Wizard of Networking. Paul Coggin is from Huntsville, Alabama. He is with Dynetics, which literally he works for rocket scientists. So to give you an idea, I was down there one time and I had a question about 802.11. Someone on his team answered it because he helped design 802.11. Paul is the senior guy there. So without further ado, I do want to give you a warning. It's not his accent. It is actually that he will be up here with me for networking, but you'll learn a lot. Please welcome Paul Coggin.
Thank you, Bill. Don't believe anything Dave and Ben, especially Ben, say about me. Like they said, I'm Paul Coggin. I'm from Huntsville, Alabama. What can I say? I just need to thank the Parameter guys for putting on just an awesome event and letting me be a part of it again this year. The hospitality, the way they treat us speakers is just unreal. It's an awesome place, how they take care of us here. But let me get into this talk here. We're going to dive into some deep service provider networking topics. This talk was derived because I don't know if you've been following in the news a lot about what's happening with BGP protocol, the protocol that runs the global internet, how IP addresses get advertised end to end for being hijacked. And so that got me thinking about MPLS networks because I build service provider networks. That's my background, is doing consulting on large, complex, critical infrastructure, telecommunications networks, about how the whole core infrastructure works. And it got me thinking that if the BGP is being hijacked, the MPLS networks, the wide area network traffic that we're all buying for private network services, it could be getting hijacked as well. Because the networks that I build, when I install a router, they're literally, some of them are as big as one of those doors there. We call them BFRs, big freaking routers. I mean, they're huge, huge. Same kind of router, you know, that you would buy for your enterprise or a remote location. It just scales hugely more. You know, it's just populated with lots of 10, 40, 100 gig cards. But so you've heard about YouTube. You might have heard about Facebook hijackings in the past. In the more recent times, you might have heard about where a service provider in Canada, one of the engineers, started advertising routes for other organizations in order so that he could hijack Bitcoin activities because he wanted to steal Bitcoin up in Canada. That happened not too long ago. Most recently, an event that happened, there was an organization that was involved with nuclear activities in the UK. Their IP address space that they advertise out to the global internet that they own was hijacked by an organization out of the Ukraine. It's always accidentally, of course. And so when they started advertising the IP address space for these different organizations, traffic gets redirected in the global internet, and any traffic that they can influence, they can do a macro level man in the middle. It's not the art poison attack we do in a local VLAN, but doing the same kind of attacks that you would do in a local VLAN, but doing it at a global level via BGP hacks. Now, so that got me thinking about this. And so here, if you give you a little bit of background on BGP, what happens is if you have multiple connections to the global internet and you want to be able to do load balance and you want to be able to do real-time failover in case one of your links to the internet drops, you're going to run BGP to the global internet, and you're going to go to ARIN. In the US, you would go to ARIN. In Europe, you'd go to RIPE. And there's other organizations around the world, depending on where you're geographically located, you would go to, so that you could get an AS number, an autonomous system number. And they would also give you independent IP addresses that you would own, that your service provider doesn't own, that you would own, that you could announce to the internet, and you could go and fail over, say if there's a link outage, or you could configure your traffic so that it's load balanced. Even if you're not doing that as a small business or an enterprise organization, your upstream service providers are running BGP for you, and they have an autonomous system number that represents your IP address space to the world. Now, what I want to show you here is there is an implicit trust relationship at the global internet level between your AT&T, your NTT, British Telecom, Quest, Sprint. They all have a trust relationship where they're advertising the IP addresses between all the networks. And if someone in a different part of the world, mischievously, some criminal, someone under the influence of organized crime or a nation state, or someone accidentally, because like I said, it's always an accident, right? Decides to put in your IP address numbers, they could start advertising your routes. Just like you configure your router for your small enterprise business, they're configuring the same kind of router interface. They put that in to BGP and start advertising your routes. The routes could get influenced and swung over like we see here. And the longest prefix is going to win. So if they have the best path to your network, traffic is going to get swung over to them. This has happened here recently. Well, actually a couple years ago, a really big hijacking happened out of China for a large percentage of traffic out of the U.S. And also saw where there was some traffic for the U.S. government being hijacked accidentally because it was a misconfigured router out of Brazil as well. So this is happening all the time. In these routers that run the BGP for the global internet, they're also the same routers that are operating and providing your MPLS services that you may buy buying as a enterprise. Because what we do is we take these routers and we virtualize them just like you do your servers, and we offer all these different services. Now, and so what I want you to get out of this is walk away from, if BGP is being hijacked, and it's all out in the press about how IP prefixes are being hijacked, if they're hijacking the BGP IP prefixes, if you're a criminal, if it's a nation state that's behind it, why would they not go after the private MPLS networks as well? Now, we're able, in the public space, on the public internet, we're able to watch and monitor your IP BGP prefixes and tell if somebody is influencing your routes and starting to hijack your routes or accidentally misconfigured and hijack. You can see that on the public internet, but only you in your enterprise MPLS wide area network can see that new routes are being advertised into your network. Or if it's being hijacked and maybe routes are not being injected and traffic's just being sniffed, only in the service provider network will they be able to tell that. But the public, somebody else, Brian Krebs is not going to be able to monitor it on your behalf and tell you, if you're using Brian for your IDS. So here's a key concept again with VPNs. We talk a lot about in this industry here lately about how our definitions of concepts have been hijacked. VPN is one of them. VPN does not imply encryption. Despite all the marketing hype, what we've been led to believe, VPN could be your VLAN, VPN could be frame relay, VPN could be ATM circuits, could be the old GRE tunnels that you might be using for tunneling your IP traffic over the internet. It's not encrypted until you overlay those tunnels with encryption. MPLS-VPN does not imply encryption. It is not encrypted. The MPLS wide area network services that you have, if you do not go and add encryption on purpose, that MPLS wide area network is not encrypted. Some people get it, majority of people don't. They're rolling out MPLS wide area networks, and I love MPLS networks. I build them. I love them. I'm a big believer in it. But I want you to understand the trust relationship that you're inheriting from the service provider, that if the service provider gets hacked, or if the service provider is compromised by an insider threat, you're inheriting that risk, and your private enterprise wide area network is being exposed. So here's where MPLS works on the OSI model. MPLS operates in the service provider backbone at what we call layer 2.5. It's a shim that gets injected between layer 2 and layer 3, between the Ethernet header, because everybody's using Ethernet these days. So between the layer 2 Ethernet header, say, and your IP header. And you'd have a label for like traffic engineering and labels for VPNs, and that all gets injected right there at layer 2, what we call layer 2.5. Now, if someone's able to influence that in your wide area network, they're going to be able to own the rest of the network. Now, I'm not going to read this PCAP to you, and these slides are available. I've given them to Ben, and they can share them with you. I can share them with you if you want them. They're out on the web. if you want to look at this in more detail. But here's a PCAP that shows you how the MPLS labels are injected between the Ethernet frame header and the IP header. I want you to get this, because there's a lot of books out there on MPLS, and you can go get all kinds of certifications from Juniper, Cisco, etc. And a lot of the books do not show you what the actual packet looks like. Well, here's what the packet looks like, an example. Now, here's what the service provider core network looks like. You have what's called P nodes in the very core, and they're just speeds and feeds. That's your BFRs, your big freaking routers. They're just pumping packets as fast as they can across the core backbone of the network. Where the action is happening, where the trust relationship that you should be concerned about happens, is at those PE routers. The PE routers are the provider edge routers, and that's where the service provider is providing services to all their customers. That's where your Metro Ethernet's being aggregated, your voice over IP services, your internet links, your private MPLS VPN circuits, and not just yours, but all of their customers are being aggregated across those provider edge routers, depending on how you jump onto their network geographically. And whoever has access to those PE routers, those provider edge routers, that's who's hijacking the BGP for the global internet. Now, I want you to get into the mindset, whoever has access to that, if you're a criminal or you're a nation state in doing this, why would you leave? Why would you not go ahead and hijack those private enterprise wide area network circuits? There's probably some good, juicy information in that. And so what I want you to get is, as you move to the edge, that CE is the customer edge device, and that's the router that is located at your small, medium enterprise business. That is your router. You may have outsourced it to the telco service provider to manage it for you, or you manage that router yourself. But that's, if you want to secure that trust relationship that you have between your customer edge router and that provider edge router, you've got to go and overlay encryption. And my recommendation is going to be, is to use a third, if you want to outsource that, because a lot of telcos, a lot of organizations want to outsource the wide area network and have the service provider manage all their routers for them and provide a lights out service, and that's great. But somebody else needs to do the encryption. Somebody else needs to do the encryption. And if you don't want to manage that VPN device, outsource it to an independent third party. So you have some separation of roles and responsibilities there. Now here's what the config looks like. There's no magic. This is real simple of how it happens for identifying a customer VPN. You go in and create an IP VERF and give a description and create the route descriptor. And then you go and specify with the route target statements you see there what VPNs, what MPLS VPNs you want to import and export. And so if someone wants to build out a wide area network, you just go and the service provider just goes and specifies the VPNs for that specific customer that they want to import and export, and associate those VPNs to the interfaces that the customers are getting aggregated to, as you see there. Or if you had a B2B situation or a merger where you got like a couple banks that have an MPLS circuits and they want to merge together, then you could go and import and export other VPNs in that network with those route target statements. Very, very simple. But what if you're a criminal or a nation state, or you're just somebody that's been mischievous, that's gone rogue, that works for a service provider, or accidentally fat fingers a router config? I've been programming routers since '97. I accidentally put in wrong commands all the time. You could fat finger and put in the wrong VPN, and what would happen is with that route, that import export, you could bleed in or bleed out networks that you did not intend to. Very, very easily. And the only way to protect yourself from the service provider being hacked or having a rogue network engineer or a misconfiguration is the VPN. You got to have your own VPN to protect yourself against this. So here's what the routing table would look like to go and reinforce the idea of the virtualization that the MPLS does for you. Just like what you guys do on the enterprise with virtualizing servers and carving up a server into virtual servers. That's what we're doing with the MPLS, as we showed you. So you'd go in and do like a show IP route in the upper left-hand corner, like you do in your global routing table, and it would spit out your global routes. But when you turn on the MPLS, Now, if you want to see customer A, customer B, you have to go do a show IP route and specify that customer VERF, that customer VPN that you want to see routes for. And so what happens, you end up like ships in the night. Everybody's routing the same physical iron and the same pipes, the same fiber, the same copper. If you're in the same router, but you're separated. You're logically separated. Now this is I talked to you about those PE routers. This is a PCAP that shows how those route target statements are advertised from one side of the service provider network over to the other, from PE to PE using BGP. The route target statements are injected using extended community strings in BGP and to advertise from router to router. And this is a PCAP that shows you that. I wanted you to see the PCAP for offline analysis so you can understand what's happening here. So how would someone go and get access to a telco? Because, you know, it's the cloud, right? The cloud's secure, right? It's the magic cloud. We put in all of our Visio drawings. There's no problems in the cloud. Everything's taken care of. It's all, you know, unicorns and rainbows in the cloud. Well, here's a strategy that I use, because this is my role and my responsibility is to design, implement, troubleshoot, secure, and figure out how to break into these networks. I do the bookends when it comes to layer 1 through 4 for network infrastructure. So here's a strategy to go after the network that I've used to break into these networks that everybody thinks can't be broke into. All you got to do is the same thing that we would do for an enterprise. Go and see what kind of intel has been leaked out. What are the trust relationships? What are the vendors? What are the mistakes that the vendors do? What are the systems and implementations that the vendors implement? How do they remotely access? Because all of the vendors that are building out these huge networks, they want remote access into those networks to support the products and systems and applications that they're installing in these networks. Because Bubba Toolbelt, Bubba Bucket Truck that gets promoted from, you know, going out and punching down wires and turning up DSL, or, you know, running fiber along the interstate, if he moves into the data center, if he goes and moves into a role on the inside of the central office, he's not going to be a network guru. He's not going to be a CCIE or a Juniper certified guy. He's going to need help. And that that vendor needs to keep these systems working, so they're going to make sure that they have access into that network to keep things operating. And so you're going to go take all that analysis, and then you're going to go develop an attack tree and come up with a strategy to how you're going to go into that network. If you do a good job here, you're going to be successful. Now here's an architecture representation for what we call a monolithic service provider architecture. This is a single service provider. I mentioned to someone at another conference over a year ago that I was working on this presentation. I had this idea and I was going to talk about it. And the gentleman told me they better listen to you, because I caught IP addresses from another country that will not be named. It's not the one you're thinking about. It's not China. It's another country. You wouldn't be surprised at. Coming out of his MPLS private virtual network, out his internet firewall. And it was out of this architecture as a single service provider. All of his networks were under the domain of a single service provider somewhere in the U.S. And he caught the traffic coming from the telco out his internet firewall. And so it obviously has to happen. Either the telco was hacked, the telco has an insider that's gone rogue and turned on this IP network from another country, or maybe they had a supply chain. I don't know. But they got hacked and turned around and hacked this contact that I have and validated this architecture. So what could they do? Somebody gets into that architecture, they flow through that attack tree, and they get into a telco. Well, one, they could go and maybe, or if you're familiar with creating GRE tunnels, any of you guys create GRE tunnels for site-to-site VPNs, if you've got the experience from the old days, where we used to use GRE tunnels for running AppleTalk, IPX, and all of the other protocols across the IP network. Well, you could go and create a GRE tunnel back into the telco service provider router and then go join some customers' MPLS private network. Or maybe the hacker, the criminal rather, whoever the criminal hacker is, Maybe they go and use ER span. If you saw the presentation that I did last year, bending and twisting networks, maybe they use that ER span capability I told you about, where you could do port mirroring, and instead of mirroring port to port, you do a port mirror, you mirror a port to an IP address and send the traffic that is of interest to you for a certain network out to a remote IP address somewhere out in the world. Or if it's someone on the inside, maybe they go and do the old classic layer 2 attacks and start sniffing your traffic right off the core backbone. I can tell you, I work in the cloud, the original Visio cloud, not the the whole data center cloud, but the original WAN cloud. We can sniff traffic right off the core backbone. It's very, very easy. It can sniff the traffic at 10 gig. It's no big deal, and do a full PCAP and parse through traffic. So if somebody goes rogue in that cloud, it's easy to go and sniff your traffic. Maybe we could go do an L2TP v3 tunnel that we show, where we could go and basically drag and drop, do a pseudo wire where you drag and drop a VLAN across a routed network, so that, say, VLAN 12 shows up not only on your local network, but shows up somewhere else in the world. It's very easy to do if you have control of those routers. Another way that you may get access, down there in the bottom right-hand corner here, what we have is we have some customer edge routers, and where I come up with the idea for this is I had a customer that had around 60 remote sites with a telco, an incumbent, and we got brought in to help them transition to a second telco. And the first telco abandoned all their equipment in place because the contract had ran out, and the equipment had been end of sale, end of life. It was in that process. And so the program manager, the guy who drives the Excel, he just abandoned all the equipment in place because it was of no value. The equipment was useless. It was not going to be used anymore, and they did not want the equipment returned. But what the incumbent program manager who made that executive decision to leave 60 routers out in the field, he did not think about that those routers got passwords, they got IP addresses, it defines all the trust relationships for like the radius servers, the IP addresses of the radius servers, the keys for connecting to the radius servers, the SNMP community strings, they got security, they got access lists on everything, but they give you all the IP addresses of all the devices that are trusted. So you know now how to go and craft and spoof packets and directly what systems to go target up there in that upper core where the network operations are. And so someone could go and possibly take that type of information and head north and develop an attack strategy to head north into that network and get into that NOC, and maybe they go and they get into the wide area network, the IP-based wide area network, the MPLS network. Maybe they're able to pivot over into the optical network and get down to, maybe they were able to pivot and get into the DWDM system where light frequencies are split up into different lambdas with DWDM, and maybe you're going to attack layer 0. Or they're going to attack the layer 2 infrastructure because they've got all that intel. That's one strategy, and able to pivot over maybe into the middleware, to the IPTV network, into the middleware or the voice network. This is how things go down. This is one strategy. Now, what we have here, this was my original thought when I started thinking about this problem many years ago. I was contemplating whether I would go share this information or not. This was my original fear when I started building these networks and got into hacking service providers. My thought was, you go and build out an MPLS network, maybe you have circuits here from St. Louis dropping out in Southeast Asia, South Central America, maybe Western and Eastern Europe. If you're a large organization and you have an MPLS wide area network like some of my enterprise customers do, where your network has a footprint around the world globally, Don't think that because you got one bill from the service provider, you got one bill for your internet, your voice, and your private wide area network services, and it's all coming from one vendor, that your network is only traversing that one vendor. They do not own the whole global network, telecommunications network. They have peering relationships, just like the internet has BGP peering relationships, so that we can all go surf the web and and all the spammers can get to us from around the world. The same thing's happening with the telco world, with the old TDM legacy networks and with the MPLS networks, where they have peering agreements so that you can have an MPLS wide area network and drop a circuit in here in St. Louis and drop it out in Southeast Asia. And so they have meet points, cross connects, where they tie their networks together. And so this is how, if someone is somewhere in the world is hijacking the BGP, and that router you see right there where it ties those square boxes together, if someone in one of those organizations is hijacking BGP, why would they not go ahead while they got access to that router, go and start hijacking MPLS-VPNs while they're at it? And my question to you, if that kind of attack is happening, either locally, you got that monolithic architecture, where you guys got one service provider and you've got one geographic footprint, say here in the U.S. Maybe you're just in the Midwest and the Southeast, and it's all under one telco service provider. Or maybe you're a global conglomerate and you've got circuits all over the world. Would you know? Are you protected against someone doing macro level attacks and sniffing your traffic, modifying and injecting your traffic? Would you know it? Or do you have means in place to protect the confidentiality and the integrity of your network? Because all those things that we talked about previously there, like the ER span of mirroring traffic out from one interface to another, and maybe mirroring traffic out and sending it out to an IP address, all of those things are possible. It could be that they could use traffic engineering and reroute your traffic along a path so that traffic could be sniffed and captured without you knowing it. Because one of the things that you can do in the MPLS network is, we got the trace route where you're going and hopping. You can go and trace out router hops. Well, you can turn off the trace route capability in MPLS, and so you do not know that your router paths have changed. You don't know that you're making hops now, maybe across 3 or 4 new routers to get your traffic redirected to a location where the infrastructure is in place to influence your network in some way, and you would never know it. The only way you would know it is if you had a baseline of time, because you can't change the physics of time, but you can hide routers, but you can't hide the fact that the timing has changed. The TTL, the actual delay rather, has changed. So I really want to impose on you that you have to have encryption on those networks. Now, some recommendations on the BGP side. If you're not already monitoring your IP prefixes, you need to be monitoring your BGP IP prefixes, your IP networks. You may be a small, medium business. You may be an enterprise. Regardless, you need to take responsibility for the IP prefixes that you have been allocated by Aaron or that you've been allocated by your service provider. You need to monitor your IP address spaces. You could go out and do it manually from the BGP Looking Glass. You can go and do a Google on BGP Looking Glass, and there's BGP servers around the world that you can go and look at and monitor and get a baseline of how your routes look around the world. But that's going to be hard to keep up. Or you could go and subscribe to a service like BGPMon. BGPMon, they offer a service where you can put in your IP networks that you own, that have been allocated to you. You might be leasing from an upstream provider, and they would proactively alert you when something's happened. But I want you to take it a step further because, one of the hot topics now, all the cool kids are talking about threat intel. I mean, if I hear threat intel 20 times a day, one of the vectors for threat intel, why not go and not only monitor your IP prefixes, but monitor your peers, your competitors, your suppliers? If your competitors are being hijacked, or your suppliers, or your customers, maybe you're next, or they've already done it to you, and you just weren't monitoring at the time. But it would give you some intel on on activities in your network. On the MPLS side, you've got to go and put encryption on your MPLS network. On those private MPLS wide area network circuits you have over your VPNs, you need to be encrypting that. I also encourage you to baseline and monitor and filter the routes that are being injected into your network. And know what networks should be coming in and being bled into your network, what should be injected into your local enclaves around your wide area network, and whitelist them. Everybody wants to beat on the Microsoft desktop guy and the server guy. Well, us network guys need to go and step up and fix our own problems. We can stop a lot of the problems from spreading code in our networks. And so why not apply network whitelisting? Start at layer 3. It's real easy to do layer 3 whitelisting. We could explicitly define the networks that we expect to be injected into our network routing tables, and anything that is not expected, we should log and run down and hold somebody accountable. Is somebody trying to help us with the network in the cloud? Do we got a service provider that's wanting to feed us some routes? Maybe they're trying to feed us some prefixes that are not ours, or maybe somebody's trying to inject prefixes from another location that we don't expect. If we're not monitoring that, and if we're not filtering that, how do we know? And the other thing I would highly recommend is to move to two-factor authentication. If you're using static passwords, your static passwords, somebody's got a copy of them, they're hacked. You got to go two-factor authentication. And the bad guys know what we see when we go in and break into routers. All we got to do is get passwords, and we can log into everybody's routers, all the switches, and we take everything over. The only way to help stop and prevent that is to get two-factor authentication in place, one-time passwords, to help control that influence if somebody gets access into the network, to separate that out so that the network infrastructure is more secure. Now, here's some references. Again, I'm going to give you these slides. They're available, so if you want to go dig in and get more information and dig deeper, these are the smart people that I follow and read. I highly recommend, if you're really interested in MPLS, you need to follow the guys from ERNW in Germany. Eno and his team are world class. They go much deeper than I do with their research in layer 2, layer 3 hacking. Especially IPv6. They're huge in IPv6 right now. And Yvonne, also known as iOS Hints, out on Twitter. You want to go and check out Yvonne at iOS Hints on Twitter at ipspace.net. He's got a huge blog site with tons of resources. Go check those guys out, and there's some other books there. Like I said, don't try to copy this all down. I'll give you the slides where you can dig into it further if you're really interested in MPLS and network core security. But those are two of my favorite guys to keep up with. We covered a lot of topics, information here. Is there any questions? Anybody got any questions? Well, if they tell you that they have an MPLS wide area network, as an auditor, you can go and verify that they're using encryption. And you should be able to go into an audit and see that, just like you would go and do audits and audit their firewalls, you should be able to go and do an audit and verify that they have VPNs. And I would, as an auditor, I would want to make sure that that VPN was not managed by the same service provider that's providing the MPLS-VPN circuit. Because if that MPLS-VPN service provider gets hacked, well, the firewall VPN is going to get hacked too through the trust relationship. You need a separation of roles and responsibilities there. My experience is the network infrastructure is being ignored by auditors in general, and that's the reason Bubba from Alabama can make a living doing this, because I focus on layer 1 through 4, and I go in and it's low-hanging fruit. because most of the time the auditors are totally missing it. It may be, what I see mostly is it's a function of time and it's a function of training, because everyone is trained up on Microsoft, and they may know a little bit about network. Cisco maybe know a little bit about it, but they don't know enough. And so there's a lack of training on that side, on understanding the network infrastructure configs. And since nobody understands it, everybody ignores it, and everybody gets an A on that. Because last thing I want to do, because everybody's got an ego. I've got one that's it's bigger than most people's. Nobody wants to admit that they don't know something. And so this is running under the radar. But I want to make people aware of it. And especially auditors, to be looking for encryption, because this is happening. I've already talked to one person who come up and admitted to me that they've been hacked. I won't say who and say where, but they called traffic from a foreign country coming out their private MPLS-VPN network. And if it's happened to them, how many other people is it happening to? Most of the networks, they don't know. If I'm successful in what I'm doing, they don't know until we show up with a slide deck and do an out briefing. But if you want to know, if you got implementation tool, if you want to put tools in place to know, NetFlow, you paid for these routers. You probably have NetFlow capability. Get NetFlow. If you're not a Cisco shop, get SFlow, or if you're a Juniper shop, the JFlow. Get that telemetry data of who's talking to who, where, when, and how much. That's what NetFlow is. It's not the full PCAP. It's the session layer information. A good friend of mine, Omar Santos, who is over the PCERT team for Cisco, he's actually got a book coming out in September. Get Omar Santos's NetFlow book when it comes out in September. I've got mine pre-ordered. I just talked to him in Puerto Rico last week at besides Puerto Rico, and he told me about it. And he's going to do a deep dive in NetFlow and mining the statistics so that you can get those indicators and detect that needle in the haystack of, say, that day zero that nobody knows about. That's NetFlow is a baseline. And then simple syslog, get Kiwi syslog going. Who's logging into your routers, when, where, and how, and why? Kiwi is real easy to turn on, or turn on syslog on a Unix box. Get all your network infrastructure pointing back to it. And then look at the next step would be to look at maybe implementing TACACs so that you could separate roles and responsibilities of who has access to run certain commands. And if you start seeing people trying to run commands that are not expected, but and make configuration changes that are not scheduled, maybe we have an opportunity for counseling, or maybe we have somebody that's got access to the network outside of the organization. But I would start with NetFlow, get syslog going, maybe and authenticate to an external radius server, and maybe two-factor authentication. And the next step, look at maybe TACACs, where you're separating the roles and responsibilities out. That's the best place to start. And then you could go and spread into, like rolling out Security Onion and getting your IDS and things in place. But NetFlow is day one. Get NetFlow. That way you can baseline who's talking to who, where, when, and how much, and what's normal. And if you start seeing your routers, why would your routers be talking to a network outside of your IP space? Routers should talk to routers, right? If you start seeing somebody connecting to your routers, SSH, SNMP from other IP addresses you don't expect, or at abnormal times, maybe you need to influence things. And also have configuration monitoring happen, so that if somebody makes a change in the configs, you're continuously archiving, so that you know what the config changes are. You know what normal is. This is just a few ideas. Any more questions? I know some people in Europe that are working with it, but I have not run into any of my customers that are rolling it out yet. If you can get everyone, it's kind of like IPv6. It's a wonderful idea, you go first. You know, so it's going to be one of those things. I think it's going. I think eventually it could help, but it's going to be really slow to be rolled out. I'm not seeing a lot of traction in the customers that I have with rolling that out. I know people in, like I said, in Europe that have looked at it, but I don't know, none of my customers in the U.S. have played with it. Yes. I started developing this presentation under the speculation that I believe it's widespread and nobody's talking about it because nobody's looking. And then I've got one indicator where somebody's told me that they have seen it happen to them. So, you know, most organizations are not going to openly talk about it because privacy, you know, compliance, need to know, liabilities. You know, it's none of my business if I'm not under contract with them to know those things. But I know there's nobody that's not being talked about. You know, people aren't talking about it until they wait till Brian Krebs, you know, go publishes an article about it, and then everybody starts talking about it. But I believe it's happening widespread. Yes. Well, if you're going, I'm a big proponent of going to the public cloud because the private networks are hacked anyway. And I'm out of the opinion now that the public cloud has probably got a better chance of being secure because you're going to have more highly skilled, hopefully a higher concentration of professionals that are going to figure out the problems, and they're going to figure out the solutions so that they'll scale, versus what we're dealing with now, with there being a shortage of skilled resources. With the cloud, with Google, Amazon services, they're going to have a higher concentration of highly skilled people with configuration management, monitoring, with like ITIL processes that are going to be more with better monitoring. So, but as a end user, if I was going to push all my data up to the cloud, encryption. You better have a solution for encryption over the wire and encryption when the data's at rest. The same problem we have now. If the bad guys get in, the data's unencrypted so they can exfil it and use it. I'm not aware of anything. I haven't personally experienced it. You know, I read what you read, but I haven't experienced anything personally. But I'm becoming, the more I live in this industry, work in this industry, I'm becoming really jaded and think, just push it all to the cloud because they're already in the private network. So the public clouds are somewhat new. It's new stuff getting spun up. We have a better chance. Roll it out clean. Like I said, I'm getting jaded. Any more questions? Well, it all comes down to the trust relationships and your trust relationships and your SLAs, your service-level agreements, the confidence you have in the organization that's going to provide your service, how consistent they're going to roll out services and have a standard process for securing their infrastructure. But you've got to, at the end of the day, whether you go public cloud or private, we've got to go and get things encrypted, whether when it's in transit, when it's moving across the networks, and when it's at rest. This is the same problem. But I prefer either going public or private, because the hybrids are going to be hard to lock down. It can be locked down. It's just depending on the time spent doing the security systems engineering. That's where it falls apart as the security systems engineering, laying out those trust relationships and what the traffic flows and who needs to talk to who, where, when, and how much. And if we're not doing it in the private cloud, what makes us think we're going to do it in the hybrid cloud? I got more confidence that the public cloud will do it. Any questions? All right. Well, I appreciate your time. If you got any questions, you want to talk to me offline, I'll be glad to provide the slides and point you to more resources to help you out. Thank y'all. Appreciate it.